Good day everyone and welcome to Learn with Mike. So for today's topic, it's about projectile motion, part 1. Let's start. So before we proceed with the projectile motion, let's have a prerequisite or review about motion in two dimensions. So we have motion in horizontal dimension and motion in vertical dimension. Motion in horizontal dimension. Suppose we have a ball, and this ball moves to the right at several points. So we have point A, B, C, and D. So the ball moves to the right. So the condition is from point A to B, the velocity is 2 meters per second and the time it takes is 5 seconds. Same with other points from point B to C and from point C to D. So from here, we can say that the velocity is constant, which is 2 meters per second, and the total time is 15 seconds from point A to point B. So the question is, what is the distance or displacement traveled by the ball? So in this condition, the formula that we can use, the original formula is velocity is equal to distance over time, as we know in basic physics. So to derive distance, we just simply multiply velocity times the time. So substituting the values, we have 2 meters per second times 15 seconds is equal to cancel second, then it is equal to 30 meters. So this is for the if the case or if an object travels at constant velocity. So next situation, suppose a ball, so again it travels at different point, but they have different distances. So they go to the right, then so we have point A, point B, point C, and point D. So in this case, the ball, because they have different distance, we can say that the ball is accelerating. So the case is the initial velocity of the ball is 0. Suppose Vi is equal to 0 meters per second. And the constant acceleration, because the ball is accelerating, let's say 5 meters per second squared. So the ball is accelerating 5 meters per second squared. And the time it takes for the ball to travel from point A to D is 10 seconds. So the question is, what is the distance traveled by the ball from point A to point D? So in this case, we cannot use D is equal to Vt, okay, because we have acceleration. So here, we can use the formula D is equal to Vit plus 80 squared over 2. Okay, so where Vi is the initial velocity, T is the time, and A is the acceleration. So substituting the values, 0 m over s times 10 second plus 5 meter per second squared times 10 second square over 2. So if we multiply 0 times 10, cancel s, then it is equal to 0. Then I started getting the square of 10, which is 100, then copy 5 over 2. The next step is to cancel s squared. Then multiply 5 times 100, that is 500 meters. Then divided by 2 is 250 meters. So if the case is like this, there is acceleration, constant acceleration, so we can use this formula. So take note that this is for only horizontal dimension. So motion in horizontal dimension, these are the formulas that we can use. D is equal to Vt, D is equal to Vit plus 80 squared over 2, then Bf is equal to Vi plus 80. So where D is the distance, V is the average velocity, Vi is the initial velocity, Bf is the final velocity, A is the acceleration, and T is the time. Now, let's proceed with the motion in vertical dimension. So suppose we have a ball, but this ball is going downward, or from point A to point B, the ball is falling. So in this case, as you can see, the direction of the ball is in vertical motion. So let's say that the initial velocity of the ball is 0 meters per second, and the time it takes for the ball to fall to the ground is 2 seconds. So take note that the ball falls at a constant acceleration equal to 9.8 meters per second squared, or it is also called as the acceleration due to gravity, g. Okay, so take note that every object that is falling, it has a constant acceleration due to gravity, which is equal to 9.8 meters per second squared. Now, what is the distance traveled by the ball? So in this case, actually we can use the same formula, but the difference is we're going to change A to G. So substituting the values, so 0 times 2 plus 9.8 times 2 squared over 2. Cancel second. So 0 times 2 is 0. Then square of 2 is 4 times 9.8 over 2. Cancel s squared. 9.8 times 4 is 39.2 meters. Divided by 2 is 19.6 meters. Okay? So that is how we compute the vertical dimension for the distance. Same formula, but we need to change A to G. So in motion in vertical dimension, we use the following formulas. D is equal to VIT plus GT squared over 2. VF is equal to VI plus GT. Almost the same with the horizontal. I just change A to G. So BF squared is equal to VI squared plus 2GD. So we have two formulas for VF, or final velocity. And we can also find time if the time is unknown using the formula T is equal to square root of 2D over G, where D is the distance, VI is the initial velocity, BF is the final velocity, G is acceleration due to gravity, which is constant, 9.8 meters per second squared, and T is the time. So now, for the summary of the formula, so we have the horizontal and vertical motion. Okay, now let's proceed with the projectile motion. So, why do we have a review about horizontal and vertical motion? Because projectile motion, so let's define first, is the motion of an object thrown or projected into the air and moves along a curved path under the action of gravity only. So the object is called a projectile. Suppose it is a ball or a rock and so on. So it is called a projectile, and its path is called trajectory. So projectile motion is the combination of vertical and horizontal motions that are completely independent of each other. So this is the reason why we review vertical and horizontal motion, because projectile motion is the combination of the two. So there are two types of projectile motion. Number one is type 1 projectiles, or in some books it is called projectile 1. So they are thrown horizontally. So example. And then type 2 projectiles are thrown from the ground at an angle of less than 90 degree but more than 0 degree. So sorry, I didn't put the degree sign, but it has degree sign. 90 degrees but more than 0 degrees. So example is this one. So the difference between the two is that type 1 projectiles has no angle. Type 2 projectiles has an angle. So for this video, I will only discuss type 1 projectiles. So for my next video, I will discuss type 2 projectiles. So let's start with type 1 projectiles, or it is also called as horizontal projectile. So let's have this diagram. Suppose the ball, or what do you call this? So let's say it's a ball coming from a cannon. So it will move in two motion. First is going to x-axis or horizontal motion, but at a certain period of time, the ball will fall. And this is vertical motion, or let's say y-axis. So this path, or the path of the ball, is what we call trajectory. So from here, so it has a horizontal motion due to the direction of the initial force applied to it. At the same time, the projectile has vertical motion which is due to being pulled by the downward gravitational force. So, it has two motion, the horizontal and the vertical motion. So, the combination of horizontal and vertical motion results in a curved path called trajectory. Commonly, the shape of the trajectory is parabola or parabolic in shape. So, let's put some values. So, let's say that the initial horizontal velocity is 10 meters per second. And the time it takes for it to fall to the ground is 30 seconds. So what do you think is the value of the dy, or the vertical distance? And what is the value of the horizontal distance, which is the dx? So sometimes horizontal distance is also called as range. So question, what is the vertical distance or height traveled by the projectile? And number 2, what is the horizontal distance or range traveled by the projectile? So in this case, we can use the following formulas. Dx for horizontal distance is equal to vi times time. Dy is equal to vit plus gt squared over 2 for vertical distance. And extra formula, vf is equal to vi plus gt, final velocity. And we have the time, square root of 2d over g. So because the unknown is dx and dy, so that is the only formula that we will use. So let's start by computing the dx. The formula is vi times t. So simply 10 times 3, cancel s. So dx is equal to 30 meters. And for dy, the formula is vit plus gt squared over 2. Substituting the values, 10 times 3 plus 9.8 times 3 squared over 2. So cancel some of the units. So 10 times 3 is 30, then 3 times 3 is 9, then times 9.8 is 88.2 meters over 2. Then dividing 88.2 meters to 2 is 44.1 meters. Then add to 30, that is 74.1 meters. Okay, so now let's have an example problem. A little girl throws her Jackson ball horizontally out of the window with a velocity of 30 meters per second. If the window is 3 meters above the ground level, then how far from the house will the ball land? So let's write the given. We have vi, which is 30 meters per second. dy is 3 meters and g is 9.8 meters per second squared. G is always there. And the unknown is the dx. So the formula for dx is vi times t. But the problem is, we have vi, which is 30, but we don't have time. So the first thing that we need to do is to compute for time. And we have formula for time, which is square root of 2 dy over g. Substituting the values, 2 times 3 over 9.8. So 2 times 3 is 6, divided by 9.8 meter per second squared. So cancel m. 6 divided by 9.8 is 0.61 seconds squared. Then square root of that is 0.78 second. Take note, I rounded off the values to 2 decimal places. Okay? So, now that we have the time, we can now compute for the dx or horizontal distance. So, using the formula, we just need to multiply. So, 30 times 0.78, cancel s. Then the answer is 23.4 meters. So, that is the value of the dx or the range. Next problem. A ball is thrown horizontally out of the window with a velocity of 3.5 meters per second. If the window is 5 meters above the ground, how far will the ball travel before it hits the ground? Okay, so this problem is almost the same with the first. So given, we have vi is equal to 3.5 meters per second, dy is equal to 5 meters, and g is 9.8 meters per second squared. I'm sorry with the noise. Okay, so unknown here is the dx. So solution, so once again, the formula is vi times time, but we don't have time, so let's get the time. So same formula is square root of 2 dy over g. Then substituting the values, 2 times 5 divided by 9.8. So we have 10 divided by 10 over 9.8. Cancel m. Then 10 divided by 9.8 is equal to 1.02 seconds squared. Getting the square root, it is equal to 1.01 second. Then let's find the dx. The formula is dx is equal to vit. Substituting the values, we have 3.5 meters per second times 1.01 second. then dx, cancel s, then dx is equal to 3.54 meters. So now for my last example, a ball is rolled off the edge of a dining table 1.5 meter high with a horizontal velocity of 2.2 meters per second. With what velocity does it strike the ground? And the other question, how far from the edge of the table did it land on the floor? Okay, so in this case, we have two unknowns. For letter A, the velocity that when it strikes the ground, so it's the VF. And then letter B is the dx. So how far? It's the dx. So given, we have VI is equal to 2.2 meters per second, dy is 1.5 meters, and G is equal to 9.8 meters per second squared. So we have two unknown, the BF and the dx. So for the solution, we use the following formulas. BF is equal to VI plus GT, and dx is equal to VI times t. But the problem is, we don't have time. So let's find the time first. So same formula, square root of 2 dy over g, substituting the values. 2 times 1.5 over 9.8. So 2 times 1.5 is 30 divided by 9.8. So cancel m. It is equal to square root of 3.06 seconds squared. Then, getting the square root, that is 1.75 seconds. Now that we have the time, we can now compute the VF. So using the formula, BF is equal to VI plus GT. Substituting the values, 2.2 meters per second plus 9.8 meters per second squared times 1.75. Let's start by multiplying 9.8 and 1.75. So cancel square. So 2.2 meters per second plus 17.15 meters per second. So the addition is 19.35 meters per second. So that is the final velocity of the ball when it strikes the ground. And for the horizontal distance, so VI times time, 2.2 meters per second times 1.75 is cancel S. So it is equal to 3.85 meters. Okay, so thanks for watching. I hope you learn. So this topic is actually not so easy topic, but it's not so hard. Okay, so I hope you learn. Wait for my next video about projectile motion 2, which has an angle. Thank you for watching, and I hope you learn. Subscribe if you learn. Thank you.